Hi everyone. So this is part 2 of the lecture on sociobiology. So we left off on slide 7. And I think the last thing that I was discussing with you was this controversy about sociobiology when the book came out, a lot of the back and forth between researchers that followed. And I know I mentioned this before in the previous video, but for the 4th article review, it's actually 2 articles. It's still just one review. The length is the same, but it's actually 2 articles. They're really short, and it's part of this kind of back and forth between a lot of these academics. And so the 2 articles actually, one is in response to the other one. So you'll get a small snippet of what this dialogue was back and forth. And I know I mentioned this to you guys in the last video, but I've literally taken a course where we spend almost an entire semester talking about this and related topics. So I know we're fitting it all into one PowerPoint, 2 videos for you. It's a little more complex and heavy than some of the other stuff that we learned this semester, but hopefully get you guys thinking about some of these larger concepts. Okay, so slide 7. So we were talking about brain-mind dualism. So I don't know if I talked about that in the last video. I don't think I did. So either way, I'll start there. So in the last 2 bullet points on this slide, on slide 7, you'll see 2 things: biological determinism and brain-mind dualism. So I think I might have a slide for each of those. So I'll just kind of briefly talk about them just in case. Let me see. Okay, I think I have okay, so let's just go to slide 8, because I think I have a slide for both of those 2 things before I ramble on and then it's actually on one of the slides. Okay, so slide 8, so biological determinism. So here you see some bullet points. So this is, the bullet points I have are I guess the simplistic version of what biological determinism is. But I want to say that depending on who you ask, these are positive or negative things, and how am I trying to say this? Often when an argument is not biological determinism, it's often referred to as biological determinism in a way to make it seem as if that argument is irrelevant. So this is what happened with sociobiology. A lot of people said, oh, you're making a biological deterministic argument, therefore we don't want to listen to what you have to say because we know biological determinism is flawed. But one, sociobiology is not biological determinism. I'll talk about that in a second. But this is just some background on what is biological determinism, why is it negative, at least as many people perceive it to be, and especially historically. So I know I talked about this before, that in anthropology we don't use the term race, we use the term ancestry, and they're related terms, but they mean different things, because we understand, like, historically, that race is actually, is this idea of racial typology, that people can be grouped into separate and distinct categories. We understand, like, whether that's physical or behavioral or whatever, we understand that's not how it works, that there's a lot of overlap, especially when we're talking about physical traits, that there are gradations to that, and a lot of overlap. So when we're thinking about something historically, we could say, okay, yeah, historically, biological determinism is not correct. But anyway, so here are some of the things about it. So this idea that genes determine everything, a lot of people would say that's not correct, because you have to look at environment, you have to, like, and then it gets into this, like, nature versus nurture, or nature, is it a combination of nature and nurture? Biological determinism also doesn't take into account environment, and if you've been paying attention throughout this entire semester, we understand that even if we're looking at genes, that environment is a critical factor in how those genes may or may not be expressed, or whether they are evolutionary adaptive or not. So environment's always really important. Biological determinism also had a lot of racist implications. So historically, this is obviously a negative. In fact, I'm not sure, I don't know if I mentioned this on any of the slides, but there's a term called phrenology. I don't know if any of you are familiar with, and that's what this picture is depicting. So it used to be thought that you could determine based on just, like, the shape of someone's head, like, their level of intelligence. Like, we know this is completely not correct, but there was a brief time, I don't know, like 100 years ago, maybe less, that people thought this was true, and that because of that, they thought because to them races tended to have slightly differently shaped heads that implied something about intelligence, and of course we know that's like just not correct at all. So biological determinism really looked at this idea, or like surrounded this idea that genes determine everything. You cannot escape your genes. Environment wasn't a factor. There is some kind of hierarchy to people, whether you call that race or whether you just think that some people are better than others. So at its core, biological determinism is not positive in any way. It's not science in any way. However, don't confuse this idea with the idea that biology does determine a lot of things about who we are. And in fact, based on what I was saying in the first video for this PowerPoint, some would argue biology determines everything, even behavior. So like you can see why this is a little confusing and why there's a lot of debate about this, because some people would say, well, you're making a biological determinist argument with sociobiology, and we know historically biological determinism is racist, and sociobiologists would say we're not making that type of argument. We're definitely not making a racist argument, but we are saying that maybe biology plays a bigger role than we originally thought, especially when it comes to behavior. So like there's a fine line, but you can see how people would go back and forth about this. People were really hardcore in their positions on this. Okay, so the next slide. So sociobiology versus biological determinism. So are these things the same? Are they different? So this is what this slide is getting at. So first bullet point, they are not the same thing. Behaviors are adaptive. So for sociobiologists, they would say genes might influence behavior, like, well, we know they do. But we still have to take into account environment. It's still like sometimes behaviors will be adaptive or not adaptive. It was a very evolutionary approach. Which of course incorporated, biology, genetics into all that. But they said, those who were proponents of sociobiology definitely had the perspective that biology is determining a lot, not just physical, but behavioral, like for who we are as people. And that doesn't have to be negative. You don't have to pull in all of these old like racist arguments for what we're saying to be scientifically accurate. It doesn't have to be both of those things. But of course, like I said, a lot of the opponents of sociobiology would often reference this idea of biological determinism. They would say, well, you're just being a biological determinist, and we know historically that that's a very racist argument, and they would just kind of outright not want to hear anything else that these sociobiologists had to say, because they kind of came into it with that idea, like, I don't want to hear it, what you have to say we don't agree with, what you have to say is racist. And the sociobiologists were like, you're not even listening to what we're saying, like that's not what we're saying at all. And in fact, we have a lot of data to back this up, and this is something where we really need to be looking at the evidence. We can't be afraid to say, okay, we were wrong about this thing in the past, for sure. What we're saying now is, while sort of kind of similar in a way, it's not the same thing, and we're definitely not implying anything racist at all by any of this. And we can't be afraid to say we have data and evidence that we need to examine, and we shouldn't be afraid to talk about that. Okay, so let's see. So like I said, so often it was oversimplified. Like people would oversimplify this idea, and this is what's called the straw man fallacy, that people want to reduce it to something that it's basically like, so they can pick it apart. So they would often say, well, sociobiology is just biological determinism, and because it's that, therefore, like, we don't have to listen to what you have to say. It's junk science, and the sociobiologists were like, that's just like, you're not even listening to what we have to say. We have some really valid arguments. Like, this is an emerging field. We are still learning a lot. There's still evidence we're trying to gather, but there's something here that we all need to be open to understanding, and you can't come in with whatever bias that you have. Also that a lot of the arguments against sociobiology, and I think you'll get at some of this in those articles for the article review, that they often, I know I've said this so many times in this class, that whatever we're talking about, whether it's the nature of humanity or our ancestors and migration, whatever story, we often want to over-romanticize these stories and come up with some scenario where we are just like, we're adventurers, or we're special in nature, or we're so innovative. In reality, like there's always, whatever cultural phenomenon is occurring, there's always a biological, often an adaptive explanation for what we're doing. There's a reason why. But for whatever reason, a lot of these those who oppose sociobiology really had this very romanticized view of nature or humans and their specialness and we just know that's not really how it works. So before I think a lot of these academics could really get at the meat of their arguments, they were often, having problems even just initially, superficially seeing the importance of the other side, because they were outright kind of denying it based on a lot of these assumptions that they had and biases that they had. Okay, so slide 10, philosophy and sociobiology. So I know I mentioned this, I think, in the last video, that when we start talking about some of this, like the nature of knowledge, the nature of, like free will, like this gets into a lot of philosophy, and this is fine. And in fact, if you ever take any graduate level work, graduate level courses, you will often get into like this, like the philosophy of science, like the nature of science as a process versus other ways of gaining knowledge. Why, and I know we talked about this before, so I have like a dog hair on my face or something. We talked about this before with the concept, the paradigm of positivism, and that there were other paradigms through which people can, observe the world and their perspectives on the world. Positivism being just one of them. So philosophy and science, at least the nature of science and scientific inquiry, can go hand in hand often. Anyway, so philosophy and sociobiology. So I mentioned this, that brain-mind dualism. So if I were to ask you, how would I word this? If I were to ask you, like, where do you do your thinking? Like, where do you think? Where do you do your thought process? You would say, I'm assuming most of you would say, like, your brain. You do that in your brain. Your brain is a physical thing. It's an organ. It's located here. We know that's what's happening. But then if I follow that up with a question of, are the brain and the mind the same thing? I might get some different answers from you guys. Some of you might say yes, some of you might say no. I think this is an important question to ask. And we ask this in science, like, are those the same thing? We ask in science and philosophy, like, this is a thing. Are they the same thing? And if you ask, like, most biologists would say they are the same thing. There's not a separate thing you're using. You're using your brain. It's a physical process. Nerves are, what's the word? Like, there are synapses and there's a physical, biological, physiological process occurring. Like, we sometimes have a hard time conceptualizing that, whether we're thinking about who we are in our minds, in our thought processes, in our personality, how that's all connected. And so, like, you get to this question of, is there something that is separate? Is there a separate thing called the mind? Is there a separate thing that's the personality? And this is important to this debate about sociobiology, because sociobiologists would say this is all an evolutionary process. It's all physical. This is about the adaptations that have occurred for the brain and also indirectly, like, those different thought processes that occur for individuals that are going to influence the choices, the decisions and choices that they make, the behaviors that they do depending on their environment. But it's all still a physical process. And a lot of those who opposed sociobiology would say that maybe they wouldn't outright say it, some would, but many would kind of imply this idea that the brain and the mind are separate things, and that while the brain may be subject to the evolutionary process, the mind, who we are in our thought processes and our personality, and maybe even in our soul, is somehow separate and different from the brain. It is not subject to the forces of evolution. It is what separates us as humans from other animals. And then we start getting into non-scientific territory. Now, you might, as an individual, believe that you have a soul, and, like, plenty of people absolutely do, but that is not a position you can take as a scientist. So remember, we talked about this in science, that everything has to be repeatable, falsifiable, testable. That's not something you can test. You can't test whether, like, you have a soul. You can't test whether there's an afterlife. You can't test whether supernatural beings are the cause of events in our reality. Like, that's just not science. It could be accurate. It's not something we can address with science. And so when you start pulling those arguments, trying to make them scientific arguments, it doesn't really work. And especially when a lot of the actual scientific data is showing that they aren't separate things. The brain and the mind are not separate things. There's plenty of data to back that up. And to the point, like I mentioned in the previous video, that there's actually data backing up that we don't have free will. There's been some work like from neurologists looking at like decision making, and anyway, it's still kind of an emerging field, so there's a lot of research kind of coming out still, but it's definitely very interesting. So back to the slide. So so you might have heard this phrase before called the ghost in the machine. So this kind of gets at this idea, like that even amongst all of this, machinery, that there's still something else in there, like whether you want to call it a personality or a soul or just your individualness, that's separate from who you are as a biological being that has been subject to the evolutionary process. And this is a hard thing to kind of accept, that who you are physically and behaviorally is really not your choice in any way. And I think it's easier for us to understand that physically, like you can't choose to be bipedal, you're like, I'm just bipedal. But imagine if you had to take that same thought process to anything that you do, like behaviorally, or any thought process you have, that it's not, you don't really have any influence. And in fact, like you get into this, like, what's that movie? Inception, where you're like thinking about your thoughts, and then your thoughts are like, am I really thinking this? Is this like, it's craziness, it's a fun thing to be able to debate and think about. But I think for many academics, they would be like, well, maybe I don't have free will. It's actually really interesting. What are the implications for that? But I think a lot of people per this whole controversy have just been like, no, I have free will. And it's one of those, I think, topics in academia where people really have some interesting perspectives on, and like I mentioned this before, this is the nature of academia and science. We absolutely need debates. And in fact, just as a side note, unfortunately, I've been hearing a lot of this in the last few years, where there might be topics that are maybe deemed controversial, and college campuses may have a guest speaker, let's say, for example, and suddenly there are people are asking for these speakers to be banned, whether a lot of this is political, but not always. But imagine if it were political, sometimes it's someone who's on the left, sometimes it's someone who's on the right. And I think that, forget about like the politics and free speech in America, just in terms of like the nature of a university atmosphere and science, we need informed debate. We need informed discussion. Even if you think, let's say we're talking about sociobiology, even if there was someone coming in saying, I'm going to do a presentation on sociobiology at UNLV campus or CSN campus, and they're like a strong opponent of sociobiology. Maybe you're like, I think sociobiology is perfectly acceptable. You might still learn something new from that opposing opinion. It might build on your own argument. It might not. It might change your mind. Like, this is so important to science, and we cannot be afraid to have those discussions. We cannot be afraid to critique our own position. And in fact, even if you never change your mind about something, knowing the perspective of someone else, how they're viewing your position, will only strengthen your position. Like, there's so many different ways why it's really, really important to be able to have dialogue. And I think that this extends to whether we're talking about things in academia, but it also extends to things in the political sphere, that we have to be willing to hear the other side. And you might be saying, yeah, sure, okay, but there's a line. That might be your personal opinion, and I guess maybe there could be instances where that might be accurate. But I would say, like, I think we draw the line. Hold on one second, my dog's making noise. I think that we draw the line too narrowly, and I think that we need to be willing to hear what other people have to say, especially like in academia, where it's an informed opinion. And so many times I think we close off our science, our studies, our thought processes on a lot of things because we don't think that the other person has anything valid to say, and that's just not science. Like, we talked about this like in the second or third day of class, that science is about building on what other people have to say, like taking in new information. If we close it off, that's not science anymore. And it might not change your mind, it might not change the perspective. Oh my God, waffle. Waffle. She's trying to be the star of this video. Okay. Anyway, you guys heard my opinion on that. So this is important. Okay, so the last few bullet points on this slide. So even if you're like, okay, like I've heard the different perspectives on sociobiology, it seems clear, like there's a lot of data backing up that our behaviors are part of this evolutionary process, and I think probably free will might not be true, or at least part of the things that we do, the choices we make are definitely we're not really making them in that, I think that real sense. There's something else going on. Even if you were like, okay, that seems like it's probably legitimate, like I can buy into that. Like where do we go from there? So this last bullet point is feelings are chemical reactions, and you'll see that in this picture I have that it says this is love, like this is the chemical reaction. And I think this is where often people also get like really it's a difficult thing for them to accept, like that love is just a chemical reaction. But like there's so much data backing this up, whether it's the love of a mother and a newborn infant, whether it's romantic love, like whatever type of love you have, there are often very specific evolutionary reasons and explanations, and like per the picture, like hormonal and chemical reactions that explain it. Now I would say, one, like just because we can explain something doesn't mean we're explaining it away. Like you could say, sure, I understand, like when I became a mother and I held my infant for the first time, I can understand like that's just oxytocin. But it doesn't take away from like the beauty of the moment. Like you can still have both of those opinions and say like I understand why it's happening, but still be able to experience it in its fullness to who you are as a person. So if you go to the next slide, slide 11, I talk a little bit more about this. So this might be kind of a dated example, but when I was younger, because I'm old, this was a very popular movie, Dead Poets Society. So this picture you'll see is a snippet from that movie, and I'll just read it. It says, medicine, law, business, engineering, these are noble pursuits and necessary to sustain life. But poetry, beauty, romance, love, these are what we stay alive for. And I think most people, not everyone, but most people would probably agree with this to an extent, whether a little or a lot, that while we as scientists, and this is the point I want to make, like we as scientists can explain things like love, like romantic love, or mother to infant love, or any other type, like familial love, that we can explain, those things I think we hold really dear to who we are as people. We can explain them scientifically. It doesn't necessarily have to take away from the beauty of what that is. So as a personal example, like when I started learning about all of this, like in my undergrad, so years ago, I remember having a discussion with my advisor, and I was saying like I feel like I'm having some like existential crisis about like who I am as a person in the world, and about like my relationships, because like whether it's like family or other, because it's like this, it can all be explained by evolution, and it's all just an evolutionary trick. And this actually reminds me of another story. So this is maybe like 3 years ago. I was in New Orleans for a conference, and I was out like the conference for the day was over. I was there for like 3 or 4 days, and the conference usually was like 9 to 5, and then after 5 we could go out in the city and do stuff. So I was with a few friends, and we were out like doing some shopping. We were gonna grab some food, and this woman approached us, and she said, I know this is kind of strange. She's like, but my it was like her sister or something. She's getting married tomorrow, and me and the other bridesmaids are kind of putting together this really cool gift. And what we want to do is get just random strangers, like she was giving us pieces of paper. She's like, write down what you think love is. Like, what is love to you? And their plan was to then like read these as part of like their toast at the wedding. Like, love is this, love is that, which is like a really cool idea. And so we were like, yeah, we want to do that. We want to help with that. So my friend was writing like, love is, trust and communication, something, I don't know. And I wrote, love is an evolutionary trick to get you to have babies. And we were all laughing about it. And she's like, no, this is fine. She's like, we want, like a wide variety of examples. But I really, like, I felt that then, I feel it now. Like, that's what love is, like when we think about it from that evolutionary biological perspective. But that doesn't mean that Alicia, like as a person, doesn't want to be in love or, you know, anything like that. I think like you have to be able to say, I mean, you could live your life thinking, okay, I can explain all this away with biology and evolution, and it can rob you of the beauty of the moment. And that's fine, and you can buy into the lie, you know. I mean, this is what my advisor told me when I said, you know, it's all just an evolutionary trick, it's all a lie. And he was like, well, because he was married and had kids, and he was like, well, I agree with you. He's like, it is. He's like, but you could still buy into the lie. You can still buy into it. And I'm like, oh, that's true. So I think like I think that's a good point. Like you can still accept sociobiology and all the research now, because it's been like 40 years, and all of the emerging fields we have from it, and say this is truth. This is evidence-based, you know, knowledge that we have, and I can explain a lot of these emotional processes or behavioral processes by understanding the evidence and biology and genetics and all that. But that doesn't necessarily mean that it has to take away from your experiences as a person. So I think that's important. Or you could say, you know what, I buy into it. It's all a trick, and I'm just not going to buy into that lie. And then that's up to you. Like, I don't know. Okay. So slide 12. So just some emerging fields. So I kind of touched on these already. But just so we had sociobiology in the 1970s, and through that origin. And then the research that followed, we have some emerging fields. So like I mentioned before, we have evolutionary psychology, and we also have ethology and behavioral ecology. So these are just similar studies, similar fields of study, looking at how we understand the evolutionary process of behavior and decision making, and the way that environment will affect that. And like, so just so you are clear on this, it wasn't as if sociobiology was introduced in the 70s and we kind of forgot about it. Not at all. In fact, we have all these new emerging fields because of it. However, if you tell someone, like if you were like, I'm a sociobiologist, you might still find people who are like, you're what? This happens, but some people are like, no, I'm a sociobiologist. I'm not a cultural anthropologist. I'm a sociobiologist. They really want to take that hardcore biological stance in trying to explain human behavior, or, you know, like primate behavior. And I know plenty of people who would say, absolutely, sociobiology. I'm not going to reword it to make people feel uncomfortable because they have this weird notion that it's still controversial in some way. But other people still have this, will maintain that it's not correct. You know, it's up to you, for you guys to kind of, you know, see both sides of that debate. Okay, so slide 13. Let's see what happens. What was the point I was trying to make here? Oh, okay. So I think I know what I was trying to make here. So like, there's often this critique of sociobiology that, sure, we can explain a lot about biology, but what about culture? So if some of you have taken the Intro to Cultural class, I mean, I guess it depends on who you've taken it with. I teach mine from a very what's called biocultural approach. I'm not sure if the other professors do that, or if you've even taken that course. But you'll often hear this, you know, biology will explain some of it, but what about culture? There's this whole other thing, like basically everything outside of our bodies, like the interactions we have with people, the possessions we own, the things that we do in our society, like that's all cultural. There's so many interesting cultural implications that are beyond just biology. And then there are people who would say, yeah, but like that's just kind of like an extension of who we are biologically. So it's kind of a debate between that. But I would say, I think one of the points I'm trying to make on this slide is something called Dunbars number. So you'll see that in the picture. So when, I think in the first video I was talking about this, that, what was I saying? I think I was saying something like when we can understand like why we might be more willing to sacrifice or make a decision that might be detrimental to us if it has a benefit to those who are closely related to us. And often the critique to that is, well, what about when you do nice things for people you're not related to? Or what about, we see this all the time in our society, that people do things for strangers, sometimes without acknowledgement. So how do you explain that in terms of like kin selection? And so I would say like one of the counter arguments to that point is looking at population. Population is so important. A lot of researchers understand that, but I would say in my personal opinion, it's often forgotten about, and it's so vital to understanding so many of these really interesting like biological or sociocultural arguments. Population is really important. Thinking about how humans evolved, for the majority of our evolution, we lived in very small communities, like 30 to 50 people. So a lot of our adaptations are based on the fact that whoever is in our group is either very closely related to us or sort of related to us. There wasn't really something like a stranger. Even if maybe depending on the way that marriages like, you know, mating worked, whether it was like 1 million years ago or 2 million years ago, depending on that, they might be coming in from another group. There was still like a familial relationship in some way, and maybe you might not be blood related to that person, but maybe you were blood related to like their offspring or something like that. Depending on you know, like mating relationships. But so imagine that you are adapted behaviorally to the idea that everyone in your group, you're probably related to either really closely or moderately closely. So when you make those decisions about what you're doing, if it's detrimental to you, even if it's benefiting the person in your unit who is the least related to you, they're still related to you in some way. So what ends up happening, so the point of Dunbar's number is, there's actually been research on this, that because of this, the way we have evolved, and this is something I talk about when I teach the cultural class. There's actually a lot of information on this. We could talk about Dunbar's number like just for like a whole PowerPoint in itself. But basically, if I asked you, like if this is such a better example when we're in class together, but if we were sitting in class and there's like 30 of us, and I said, you know, if we were all like, imagine we were a unit, like a community unit in the evolutionary past, like 30 of us, we would all know each other's names. We would all know the personality traits of everyone. We would know who we could trust, who we couldn't. We would know who was a good hunter, who was a good gatherer, who knew the best place for the best fruit, who was really good at, you know, maybe finding herbal remedies for being sick. Like we would know who had skills, who didn't, who we could trust, who we couldn't, who was reliable, who was going to be a potentially good mate or not. We would be able to hold all of that information in our heads. We wouldn't need to write it down. We wouldn't need to have any like cultural symbology to understand that information. We would just know that information because there's such a small number of people. And in fact, for those of us in our class, 30 of us, let's say we spent a year together in the class, we would probably be able to tell a lot of the information just from each other by spending a year with each other. But there's a limit. There's a limit to how many people's social personal information you can hold in your head, and this is Dunbar's number, that it's 150. After 150, you really can't store that information in your mind. Now, we evolved in this environment where our groups were really small, so we could have all that information. It was adaptive to be able to hold all that information in our heads. But now we live in a very different world. Our brains are adapted to understanding like everyone in my community is related to me. I need to be able to store all that information, but we can't really do that. And we aren't related to everyone in our community. So what ends up happening in terms of like why we might see people being kind to other people who aren't necessarily like in their family unit is because of this, because we still have that mentality like everyone in my community is related to me in some way. It's just an extension out of that adaptation. But also, Dunbar's number implies a lot of interesting things culturally, like why we see such complex symbolism in communities where there are so many different people. So, like, I mean, this is a whole like conversation we'd have in the cultural class. But like, what are things that you do that you're trying to convey information about yourself to other people? Like, and a really good example. There are so many, and if you take the cultural class with me, we'll talk about them. But a really good example is wedding rings. Typically, depending on the culture, maybe the ring is different or the finger is different. But like in our society, we would say, okay, it's on a certain finger. There's a wedding ring, whether you're male or female. That's supposed to convey social information to other people who may not know, you personally may not know that you're married. But imagine the scenario where there was only 30 of us. You wouldn't need to have that to be able to convey that information to anybody. We wouldn't need to wear some of the clothing that we wear. We wouldn't need to do a lot of things we do to our physical bodies that are like cultural expressions, because everyone would already know information about us. We wouldn't need to like display that information, whether it's the possessions we have, like you want to buy a fancy car because you want to convey to other people you have a lot of money. For example, like, so when we live in larger groups, when population is large, so many things change biologically and culturally because of that. So that's the whole point of this slide, is that population is really important. Population size is really important. Okay, so the last slide 14. So I know I mentioned this to you guys before. Sorry, my dog was coughing. Okay. That we often, when we think about evolution, we think about things occurring at the level of the individual, and that there are these arguments that things occur at the level of the group. And I know I mentioned this to you guys in the previous lecture, that that's just not accurate. The evidence does not support that. However, there was a lot of support for taking it kind of in the opposite direction. It's not occurring at the level of maybe the individual person, but actually at the level of the gene. And one of my favorite books is called The Selfish Gene by Richard Dawkins. And it goes into this idea that we're not looking at evolution or adaptation occurring at the level of the individual, it's occurring at the level of the gene. And I'm not going to like synthesize the whole book for you guys, but I would say I've read this book like a few times. It's one of my favorite books. It's really good at getting at this idea of looking at the biological implications for like behavior, and this extends to his other book, what's called The Extended Phenotype, which I have a picture of right here, which looks at how we can extend biological explanations to what we see like behaviorally and socially. So I would just say, if you were interested in understanding some of this information further, I mean, obviously you can read Sociobiology by E.O. Wilson, and you can just Google sociobiology or even Google Scholar and see there are so many really interesting debates about this back and forth between academics, which I find very entertaining. I don't know if you guys will. But if you were just kind of generally interested in some of this stuff, I would say Richard Dawkins' Selfish Gene or Extended Phenotype kind of get at this from his personal perspective on some of this with a lot of interesting data to back it up. But there's this whole other field called memetics. And I would say like I'm a memeticist, but a lot of people like I think they don't want to accept this idea. And basically it's this idea that we can find analogies in what we do culturally and socially to things that are occurring biologically, that a lot of it's very similar, and that what we're doing in terms of like passing on information, like social or cultural information, is really similar to how we pass biological information. There's actually there's so many interesting implications for this, and like I said, with sociobiology, we see just this branching event of all these really interesting fields and subfields getting into this idea. So anyway, okay, I think that kind of wraps up this PowerPoint. I don't think there's anything else that's coming to my mind that I wanted to say. And good thing I split this into 2 videos, because both of these videos end up being a lot longer. I knew I would just talk and talk. Okay. So that's it for this one, and I won't talk to you guys, but I'll see you guys later.